Welcome to the Battery Testing Mentor podcast, a podcast about battery testing, battery safety, battery handling, battery regulations. My name is Johannes and we are exploring here every 2 weeks a new topic out of this space. Stay always up to date on what's going on in the podcast via the newsletter that I send out that you can sign up for on the website www.batterytestingmentor.com. And there I will always summarize what the content of the most recent episode is. Today I have a guest here. I'm very proud and happy to welcome Michael Becker from CSA. And I mean, he is also a special guest because he's the first guest who comes from North America into this podcast. So I'm very glad to have him here. And with that, I don't want to make any more words, but jump directly into the interview. Have fun and enjoy it. So a very warm welcome to Michael Becker here. He visits me today. He's coming from North America. I mean, he's visiting here virtually. But I'm nevertheless very, very grateful that you found the time, Michael, to come here to share a little bit about your insights about what is going on kind of from the North American perspective in stationary battery. And I welcome you very, very warmly and would give you directly the floor to give a short introduction about yourself. Like, who are you? What brought you into the battery space?
Mm-hmm. Yeah, thanks for having me on for sure to the podcast. So my name is Michael Becker. I'm the global business director at CSA Group. So CSA Group is a testing, inspection, certification company. So we basically perform testing and certification on all types of different products. So from energy storage, battery systems, all the way to consumer products, laptops, TVs, kind of across the whole breadth of product. My specialty is in energy storage, so I manage our energy storage business globally and our strategy globally for energy storage and battery systems. I've been in energy storage and battery the world for probably about, I guess it's 8, 9 years now. Before CSA, I actually worked at a battery manufacturing and development company. So I started on the development side, developing these products, testing them, and then I joined the independent kind of third party lab. So that's how I got to where I am today. And as far as CSA Group, we do testing and certification on all types of battery systems, from small batteries for like a power tool all the way up to a large scale container battery for a utility installation. And we are a global company. So we have about 2 to 3 thousand employees, 13 offices globally in different countries. I'm located in, like you said, North America, in the US. We also have offices in Europe and in Asia as well. So kind of all over the place.
Yeah. So really also a lot of insights in the markets everywhere. And I mean, basically this battery or large scale battery storage topic is also some global topic. Like you see a lot of increase in the installations everywhere, like in China, in Europe, in North America, in Australia, I don't know, like probably wherever you have a large energy storage grid and increasing shares of photovoltaics and renewables, you will have these large scale batteries as well. Um, what is your point of view? Like, what are the key drivers then to especially make it more important to have this proper testing of these large scale battery storage systems? Because I mean, you could also say, hey, they are typically standing somewhere on the field. There's only grassland around and it's fenced off. Who cares about kind of
Hmm.
safety? If it burns, it burns, and at least no people are harmed or
Hmm.
in danger. Still, I would say you see that there's more and more urgency in terms of testing these systems. What is your take on this?
Yeah, I think, like you said, the amount of deployments that are being uh, deployed and installed around the world is growing at an really exponential rate. I had one statistic that was just from the US energy storage deployments rose 57% from Q1 of 2024 to Q1 of 2025. So that's just this
Mm.
year. Utility scale installations rose 57% to about 4 gigawatt hours of energy storage in just one quarter, which is a lot of energy storage being deployed because of the power grid, the power needs, and like you said, it is a global thing. Seeing this in Asia, in Europe, in Australia, and really all over the place. Um, even though some of these installations are remote, so a lot of the utility installations might be remote, they're large installations. So there's not just one container, there might be tens or hundreds of containers deployed at a single site. And so the testing and safety becomes almost even more important because you have a lot of energy in a small footprint for these installations. So the testing isn't when you talk about safety, performance, it's about life safety and performance, but it also is looking at property and the installation and the value of the product. And so, one of the drivers that we've seen for a lot of this has also been for the insurance industry and underwriting and coverage if there is an event that happens. And so
Mm.
that would apply regardless, whether it's a remote installation or it's in a densely populated area. But you also have to think about first responders. So if there is an event, if there is a fire or something like that, you're going to have people respond to the event. And so, what are they going to be exposed to? And there's also considerations of the surrounding community. So maybe it's not next to a populated area, but if there is a fire and you have gases, emissions that can be blown into other areas that where people are at, there could be some impact to them as well.
Mm. Now, I mean, is this now my view, or do you would agree with this view that it seems like the US has in some way more stringent testing requirements for the large scale battery storage systems than other areas in the world?
So I don't know if I would define it as stringent. I think it's where the codes and regulations are
Mm.
at in the life cycle of these types of products, right? So energy storage, I think a lot of the code and standards development is in a more mature state in North America and the US than in other regions.
Mm.
There's a lot of the main standards like the UL standards, NFPA, that have defined these installations and the safety of these installations over time. And I think other regions are kind of catching up where their regulatory structure is still not 100% defined, and so there may not be stringent requirements. But we are seeing other regions like Europe, like the Middle East, like Asia, start to require similar testing that we do in North America. Even though it's not in a code or regulation, it's kind of becoming best practice or state of the art to do these types of tests, regardless of whether there's
Mm.
a technically a code requirement or not.
Yeah. Do you also see that kind of the batteries are developing? I mean, they are. You have new chemistries. You probably the LFP is much more used than 10 years ago in these
Hmm.
stationary batteries. If there were stationary batteries 10 years ago. But basically, you have, of course, the development of the systems, the designs. Um, do you think these development in the standards are a response to this kind of development, the technical development, or is it more really kind of first we need to catch up with the topic of stationary battery as a whole,
Hmm.
and therefore kind of the standards get more mature?
Hmm. Yeah, I think traditionally technology and innovation might go at a faster pace than
Mm.
standardization and regulation. Usually it lags a little bit behind. I think in North America, it's getting to a better point where it's kind of catching up with the latest technologies. There's been a lot of work on standards development committees and technical committees to adjust requirements or update them to what is being developed currently. I think, the majority of installations are still most likely lithium ion based, and like you said, a
Mm.
lot of LFP installations. So a lot of those standards in lithium ion are pretty well defined or becoming well defined, where we're getting to a good state of knowing what type of test and standards and certification to get for it. And I think the next question is how do uh, other innovative technologies or chemistries, how is that going to impact standards in the future? And so probably what will happen, I don't think a lot of them are at a point of commercialization yet where it becomes competitive with lithium ion. But once we get to a point where some of these other chemistries like sodium ion or solid state become more commercialized, then we'll probably be at the same point where then we need to work on the standards and regulations to make sure that we're catching up to those technologies as well. So I think usually the standard is catching up, but I think for lithium ion, we're getting to a good point, especially in North America with some of the codes and standards and understanding what we need to do to lower the risk of a failure happening.
Mm. Now, when we go deeper into this testing, I mean, one big point that is really gaining importance all around the world is this kind of, let's call it fire testing, where you basically really put the battery on fire, you try to get propagation, you try to see what external fire does to the battery. And I mean, if you talk to some manufacturers here in Europe, they all say, "Oh, America is a difficult, good market because they require this UL 9540A fire
Hmm.
testing, and we need to completely change our designs to be able to then sell on the American market."
Hmm.
So, would you say this is really kind of such an big challenge, or is it more this thing that looks very scary on the paper? But in the end, it is not much different to like an fuel fire test in the R100, or I mean, in China, you have now also some propagation test procedures or requirements.
Hmm.
Um, how would you say is the difference there?
Yeah, I think that's probably a good point of if there's not a lot of familiarity with the standard, it does seem
Mm,
kind of overwhelming, I think, when you first look at it. The 9540A has been around for some time now, and it has a lot of great information on testing, basically forcing thermal runaway of a system, right? And then determining the propensity of that system to have any type of fire and explosion hazards. Uh, a, a lot of that has been, a lot of that testing has been done for North America, as you said. I think it's also understanding the purpose of the testing. So a lot of people look at that test and they look at they may not fully understand the pass fail criteria. So let's say
mm,
an example, the module test where you have to have cell to cell propagation. When you look at the standard, there's not really a pass fail criteria for that test. You can have fire outside the
mm,
module. You can have a pretty serious event, but it's not a failure. The purpose of the test is to acquire data to understand what would happen in a specific scenario so that you can take that data then and evaluate specific installations to say, okay, if I put it in this installation or this one, maybe it's closer to buildings or there's other installations around it. You start to understand the boundaries of what the installation can be. So I think part of it is just better education and understanding of the purpose of the standard and
mm,
why do the testing and what you're trying to get out of it, not looking at it as a really stringent requirement per se. But I would also say I have talked with even we had talked. We were at the battery show last month. I talked with a few manufacturers who were facing the 9540A requirement in Europe. So it's not in a code, it's not in a
mm,
regulation yet, but some buyers would are requiring 9540A reports to be provided before they would approve an installation. So I would say it's kind of we're going down that path where it's going to become requirement or at least reference, whether it be in regulation or code or maybe even just a requirement from a customer. So it's probably something that could be looked at, understand it a little bit more, a little bit better to understand the purpose of the test, and then evaluate whether the product would meet the requirements or not.
mm. Yeah. Can you walk us a little bit through kind of such an UL 9540A kind of, or what are the key aspects when you really go through the test? What is really the important data you need to collect?
Yeah, for sure. So there's basically there's technically four levels, but there's three major levels that are mostly tested. So we start with the cell level test. And so when we're doing a cell level test, we put a single lithium ion cell or any type of other
Mm.
chemistry into a pressure vessel. So it's an enclosed vessel. We'll initiate thermal runaway in an inert environment, and then we'll collect the gases that come off of the cell during a thermal runaway. So we actually collect those gases and then we have to analyze them. We have to do a composition. What are in this? What's in this gas? What type of other
Mm.
gas components are in there? Hydrogen, carbon monoxide, dioxide, and other compositions. And then we also then perform various testing to understand what's the burning velocity of the gases, what's the lower flammability limit, and some of the other tests that we do after we've collected the gases and analyzed it. And so what that helps you to understand, again, it's not really a pass-fail test. It's understanding if there is a thermal runaway event, what type of gases are released, and also what's the flammability and explosion limits. Because that helps you to understand, what size room could you install this system in, because if you install it in too small of a room and you have a venting event, maybe you reach the flammability limit very quickly before you can turn on a ventilation system or an exhaust system. So it's really just to understand
Mm.
the limits of the install. So once you do the cell level test, then you do a module level test. So you kind of go to the next level. And that's really to understand if there's cell to cell propagation in a module, what type of heat, what's the heat release rate? So the rate at which heat's released, what type of smoke and other things are released, and also just how does the module design perform? Again, not really pass fail criteria, just understanding if there's cell to cell propagation for a module, what happens. And then the next level, which is kind of the final level, is the unit level test. And so what this is a full, you could think of a full rack or a full cabinet, and you initiate thermal runaway, and you're really determining what's the effect on the surrounding environment. So if you have multiple energy storage systems or racks next to each other, would there be propagation? If a single one goes into thermal runaway, would there be propagation to the other ones? If you have it mounted near a building, would there be exposure to the building where it could then affect the building or cause a more serious fire? So it's really the
Mm.
pass fail criteria is to understand, how if you say, okay, you can install two of these next to each other with a few inches of gap, then the test would verify that that is actually okay, that you're not going to have propagation between multiple energy storage units. So those are the main three levels of testing. Um, and there's newer tests I think coming off that you mentioned about the fire testing, which is a little bit different, where you have actual ignition of the gases and an actual fire. But 9540A, that's really the summary of it.
Mm. Yeah. So this is one thing you said, like this fire testing is basically something different. I mean, there is also the R100, which is also really like different tests.
Hmm.
It's
Yep.
kind of all, everybody looks at it probably from a slightly different perspective.
Yeah.
But in the end, probably the real target is always to find out how big will a fire be if the battery really goes into thermal runaway, right?
Hmm.
And what risks are there that environment is exposed to, people are exposed to, or also assets around are exposed to,
Hmm.
right?
Yeah, I think when you start looking at a lot of those different tests, you start understanding that they were really drafted with a specific application in mind,
Mm.
right? Like they're a little bit different, and you start to see why. So you think of like an R100 test, it's a mobile applications, it's a vehicle. So there's a lot of focus on understanding if there is a thermal runaway, how long does the occupant have to be able to remove themselves,
Mm.
right, from the vehicle and from the situation before it gets worse? Or you have the external fire test, because there could be a vehicle fire from something else that causes a fire, and what's the effect of that? So that's really what R100 is focused on for stationary energy storage. I think the focus is on if there is a fire. So what we've been doing a lot of is intentional fire. So if there is a venting event and there's some type of ignition and you have a fire of a whole container, like so a whole energy storage system container, does it spread to the
Mm.
adjacent containers? What people would be exposed to around it as far as toxic emissions? is another example. And then also, how would first responders like firefighters, when they approach the installation, what should they do? So it's kind of different. You're learning different things from these kind of different tests because of the
Mm,
application, but it's all important data that's being used by the end users if there is an event that happens.
yeah. So do you see that the data is then also used to kind of improve the design, or is it more like you do the test to know then how to react in the real world, and basically the battery stays as it is?
hmm I think it's both, for sure. So on one side, from the design side, there could be improvements that might be made because of the testing.
Mm,
So some of the high level ones as examples could be that if you had very small spacings and you found that you may have propagation if there was a fire, then maybe in an installation you need to space them further apart from each other. So that could
mm,
be a decision you make based on the test. The other thing could be, okay, well, we don't want to space it further apart, so maybe we need more thermal insulation between containers, on the wall or some type of installation so that it wouldn't it wouldn't propagate if there was a fire in the field. So there are definitely design elements that might be looked at if they're depending on the test and the results of the test. But then, yes, the
mm,
testing then at that point is also used in the field. A lot of times it's reviewed by code inspectors or like the fire department to understand, okay, if there is something that happens, what do we do? It's also looked at by the insurance and the underwriting industry to make sure that they know, okay, if there's a maximum loss event, what do we expect? Do we expect 30 containers to be lost or just one container? And so
mm.
that all that data helps them too.
Yeah, yeah. Is there also the other way around, basically, that in some way real world incidents and failures are changing the standards and lead to kind of certain revisions and change in the test protocols? Have you seen this as
Mhm.
well?
Well, really, that's where a lot of this fire testing came from. So
Mm,
initially, 9548 was created and has been followed for quite some time. It was a good standard, provided a lot of useful data. But one possible result from a 9548 test would be that you would just have cell venting. So you would just have gases venting and no
mm,
fire. And that's an acceptable result for 9548.
mm,
But what was happening in the field is you would have some type of ignition of the gases from some other reason,
yeah,
right? There could be moisture ingress, there could be a short circuit somewhere, you could have a failure of another component, within the system, ground fault. And so what was happening is incidents that actually happened in the field, these things were catching on fire. There would be an ignition of fire, and then it would be spreading to multiple containers because there was no testing that was really done. 9548 didn't cover that to verify, what would happen. And so that some of those incidents that happened, that then people who were improving these installations, the standards, the committees, CSA being one of them started to look at, is there a gap here in the
mm,
standard and the test methodology that we need to address? And so that's where kind of we call it large scale fire testing came from, where we now address in C800 as that standard and that test method, where it's a little bit different than 9548, but it really came out of a result of incidents that were happening in the field.
that was the first part of our interview with Michael Becker. We are continuing this conversation next week. There we dive more into the standard side, how standards across the world are developing. It is a super interesting topic, so stay tuned. I wish you a happy 2 weeks ahead and hear you soon again.